Welcome to the webinar on the basics of building retuning, or BRT. My name is Alana Colvin, and I will be hosting today's webinar. I would like to take another minute to let more people sign on, and then after that, we will continue forward. Several quick items of business before we get started. If you have any technical difficulties accessing or hearing the presentation, please use the chat pad and we'll try to correct them promptly. We'll wait to answer any specific material questions until the end of the presentation, since that will allow us to move through the material efficiently and allow enough time for questions and answers at the end. The presentation will last for approximately 50 minutes, followed by the Q&A. Also, this webinar is being recorded and will be loaded onto the PennTAP website for later viewing. The intent of today's webinar is to discuss how to combine energy efficiency strategies with preventative maintenance to achieve your energy saving goals at the lowest possible cost. This process is what we call the basics of building retuning. I would like to take a moment to acknowledge the Department of Protections and their Energy Programs Office of Pennsylvania and the Pacific Northwest National Laboratory for their support of the BRT program. In today's webinar, I will introduce building retuning and its phases. We will discuss some benchmarking tools, review how to complete a walkthrough with examples of various opportunities, share some implementation strategies with examples from other school districts, and review documentation and sustainability practices. After the BRT material, we will also review alternative PennTAP services, followed by the Q&A. The objective of this webinar is to provide you with enough background and guidance about building retuning to support your own BRT measures. So what is building retuning? Building retuning, or BRT, is a prescriptive approach to identify and correct no-cost or low-cost building operational problems that lead to energy waste. The principles of BRT are simple. If you don't need it, turn it off. If you do need it, run it efficiently. Your aim is to learn your building's personality so you can get the results you're looking for. Know where your occupants are and at what time of day. Take time to adjust your controls on your energy systems to reflect your real needs. Also, support continuous training of the staff and occupants so you're successful in reaching your goals to reduce energy costs. There are 5 phases to BRT: data collection phase, investigation phase, implementation phase, documentation phase, and the sustain phase. We will be reviewing each of these phases in greater detail throughout this webinar. So, step 1, data collection. In this phase, you will take the time to collect the information necessary to trend and to plan the building walkthrough during the investigation phase. What type of data are you looking to collect? What you want to collect is the size of your building, the age of your building, the type, meters, utility bills, the hours of the various operations, whether that be events or your HVAC zones, as-built and construction documentation if you have it, sequence of operations, the type of equipment you have, recent repairs, any equipment maintenance schedules and logs. Also review any complaint logs to indicate if there's an issue in a part or zone of your building. Also consider what the original mission was of your building and if that mission has changed. After your data is collected, you can then start to profile the information that you have for your current energy consumption and operation practices. A way to profile your data is by benchmarking. Benchmarking your energy consumption will give you a better understanding of where the energy is going, and it will help you identify where to focus your attention. As seen here, the utility usage has been broken down by systems. In the case of electricity usage, we can see that the lighting, cooling, and office equipment make up about 75% of the utility consumption. These would be target areas to focus on when implementing energy-efficient strategies. Benchmarking from scratch can be very daunting. We recommend that you work with Energy Star's Portfolio Manager or the Department of Energy's Building Energy Asset Score tool, or do both. You can use Energy Star's Portfolio Manager to manage your energy and water usage of any building. It also has the ability to share data and chart your usage for you. The U.S. Department of Energy's Energy Asset Score tool is a national standardized tool for assessing the physical and structural energy efficiency of your building. It looks at your current building and its energy usage and provides you with a score of your current state, but also provides you with a goal with where your building could be in its most efficient state. Every building is different and is being used in a specific fashion. These tools take that into account. Portfolio Manager and Asset Score are two resources available to you at no cost and will help benchmark your building. Moving forward with step 2, the investigation phase. Our goal in this phase is to identify low cost, no cost, operational problems, and energy-saving opportunities. In the investigation phase, you will want to walk down your major building operations: building envelope, HVAC systems and controls, air distribution, lighting systems and controls, hot water, office equipment, and indoor environmental conditions. Information collected in this step is used to identify the operational problems and energy-saving opportunities to plan for the implementation step of your retuning measures. It is not the goal to solve issues discovered during this phase. We will later prioritize the findings in the implementation phase. We will also be discussing each of these operations in more detail with what you should be looking for during your investigation. There are many areas to investigate during a walkthrough. Look at all building conditions and operations. Use your senses. Look, listen, smell, and when safe, touch. You want to investigate during both the heating season and the cooling season to see if everything is operating properly. You also want to log all information and observations during your walkthrough. This will help you capture opportunities and ultimately help you calculate potential energy savings. Also, as a public service announcement, please consider your safety during your walkthrough. Up first, we have building envelope. For building envelope, you want to walk down the building's perimeters, the courtyards, any bays, both inside and outside. For doors, consider if you have interior doors being used in exterior ways. The exterior doors have different insulation properties than interior doors. Look for heaters or cooling vents that you have around exterior doors. How often are they running? Are your doors leaky? For windows, are your windows fogged? Is visibility acceptable? Are they operable? Can you open and close the windows easily? Single pane, double pane, triple pane as applicable. Also consider daylight savings opportunities using the windows and therefore turning off lights. Also, in the hot summertime, consider shading the windows to keep it cool on the inside. For unsealed penetrations, consider pipes, old electrical junction boxes possibly not covered, any missing caulking, missing bricks around outlets or other areas. Also look for any rust. Rust means water is getting trapped and is standing and therefore could be eating away at your wall. Consider your plug leads. You might have outside heat traces on water lines, gutters, storm drains in the wintertime. Are these still operating in the summertime? Also consider your fans, your AC units, anything that is going to be working overtime, and whether or not those leads need to have a break or if your circuit is being overloaded. For insulation, we recommend using an infrared camera to walk the perimeter, interior and exterior, to inspect for damaged locations and penetrations and missing insulation. Also consider your doors and windows with this infrared camera. For roofs, white and clean are the most energy saving. Dirt can change the color and thus you'll lose out on your improvement. Also look for standing water. Standing water will increase the possibility for mold and leaks. And last but not least, attics and crawl spaces. Check to see that your vents are not closed up or plugged up when needing to be operational. Inspect your insulation conditions, whether there's any missing or damaged insulation. Fan temperature controls, look for pests, and also make sure that your crawl spaces are ventilated seasonally. The next few slides will review some examples of findings from walkthroughs of building envelope. In the top left corner, we have a thermal image of an exterior building. Take a moment to see what your building looks like on a cold winter day and on a hot summer day. Doing this can help you recognize insulation issues quickly. In the bottom left photo, there's a window open during the wintertime. So this poses the question, why? Is it too hot in that area and you need the room to be cooled during the winter? How many of us see this in our own buildings? This will require further investigation to get to the root cause, but now you know something more is going on with this zone. After completing the investigation of the building's envelope, it would be reasonable to review the HVAC system and its controls. Also in the right photo reveals a lot of air infiltration. Anytime you can see natural daylight under doorways or windows, you have airflow. Other envelope examples include unsealed penetrations. Are there unsealed penetrations in your building? Look for infiltration around seams or pipe penetrations in your building envelope. Improperly sealed holes will allow for an increase of infiltration into the building. In the left photo, you can see that the exterior wall has caved in, and in the right photo, that some of the insulation board has fallen. These areas are exposed to all elements, and the longer that these penetrations are left unintended, water damage, mold, pests, etc., can become a serious problem. After you have investigated the building's envelope, you want to take time to look at individual operating systems and review their current conditions as well. For HVAC, problems can occur in any number of the components: economizers, improper refrigerant levels, fans running during unoccupied hours, fans cycling on or off when requiring ventilation. Also check for low airflow. Zone changes may have happened. Multiple thermostats might now be overlapping due to a remodel or doors being opened. In the photos, you can see the seized HVAC. This was due to faulty controls. You can see the broken P-trap, and you can also see the maintenance left incomplete on the right-hand photo. Although the doors on an HVAC can be meticulous to undo and then reinstall each time, making sure that the doors are secure on means that debris will be blocked from getting in, as well as various animals. You can't guarantee the equipment is operating the same way as you left it after leaving it exposed long-term. Common problems in HVAC systems can include jammed or frozen outdoor air dampeners, missing or damaged panels, seals, ductwork, non-functioning actuators or disconnected wires, malfunctioning outdoor air or return air temperature sensors, faulty control settings, installed wrong or wired incorrectly. Also consider your equipment's coding as part of the install. Also, look for debris in the coils or the lines. Look for foreign material around the rotating equipment. Look for debris in the fan wheel or fan section. Look for insulation that has come loose, is hanging, or is falling down inside the housing or ductwork. Check for signs of belt debris or if the belts are failing. Also look for loose screws and/or bolts. Indoor air quality is a growing topic in schools and is part of all sustainability conversations. Make sure you take a moment to put eyes on your air distribution systems to confirm the conditions of the ductwork, exhaust fans, and dampeners. 10 to 30% of conditioned air is wasted due to leaks. Make sure you don't have any blockages in the ductwork or in front of your vents. Indications that you're having issues with your air duct include mold, sewage gas, exhaust fans not operating as they should be, stuffiness, other odors. Also consider condensation on windows, and if it's winter, you can see if you have quick melting snow on the roof or a warmer attic or crawl space. According to the EPA DOE, lighting could account for up to 40% of the energy used in commercial office space buildings. Strategies for your lighting can include daylight harvesting when you use natural daylight through your windows and turn off your lights, lighting controls such as occupancy sensors in rooms that are used less than others, delamping if you have upgraded your systems, maybe you don't need all the lights you previously had, and then consider lighting replacement. If you have old style of light, maybe there's something that you can upgrade to that will be more efficient, such as LEDs. When considering lighting, look around your facility and see what you have for your existing lighting. You may have fluorescent tubes, such as your T8s, T12s, or T5s. Maybe you have outside lights that have high pressure sodium vapor or metal halides in high bay areas, incandescents, or even CLFs throughout your facility. Take a look to get an idea of what you have and how you can upgrade to newer technology to save on energy costs. Consider each space. What is its purpose? Do they have any lighting controls? Is it just manual switches, or are there dimmers or time clocks? Are there proper light levels being maintained, or is the area overlit? Are there opportunities to delamp? Using a light meter, you can verify the light levels meet the IES, Illuminating Engineer Society's recommendations for that space. On the left image, this is an excerpt from their source. Consider daylighting again. Also putting up educational signs about manual light switches. And also consider if any of your lamps or fixtures are dusty or dirty, and now that's impacting your visibility. For hot water systems, consider where the water is going and how long between uses. Are you heating up water for gym showers that's never being used? Do you have insulation on all your hot water piping? Using a thermal camera can give you a sense of what your hot water system is actually doing against your assumptions. Consider your space heating, domestic hot water, your kitchens, your insulation on your tanks and your lines. Look for any external leaks and for any internal leaks, such as steam traps, if this is applicable to your school or municipality. Also check to see if your equipment is ENERGY STAR rated and whether or not it might be a good idea to upgrade. Over the past 2 decades, the use of office equipment has increased significantly and still continues to increase. You want to check to see if all your computer screens are turned on or if they're turned off. Inform staff about turning them off when not in use, such as on your weeknights and weekends, or any other holidays. Some computer equipment can be set up to be turned off automatically or go into energy saving mode. Also, I suggest eliminating clutter and preventing dust buildups to make sure the life of your equipment is reached. Consider Energy Star ratings and educating staff. Last to investigate are indoor environment conditions. Each place has a different job and should therefore be considered when you're ready to implement. Consider the different types of environments: classrooms, computer labs, libraries, locker rooms, foyers. Are you zoned accurately for these environments? When considering a project, consider the end customer. If it's in a classroom, you have educators and students, possibly for 8 hours a day. Locker rooms, you have periodic use and possibly after school hours. While completing your investigation, we recommend you take a few low-cost tools with you to help uncover any issues. Many smart tools are available nowadays and are useful in building retuning for checking temperature, humidity, airflow, and air pressure. Find problems like air leaks, missing insulation, or even electrical overloads and power lines with the Seek Thermal IR camera. Compact, teeny, and portable. This can be used with several smart devices, and what's really nice about this camera is that it can give you a running scale of temperatures, and you can have multiple set points to compare against. In the photos, you can see we have used the infrared camera to see heat lost from uninstalled pipe insulation on piping. We can see that an interior door is being used instead of an exterior door, and also therefore lacking in insulation. You can see the penetration leak, where the cool air is actually entering the building. And in the bottom left corner, you can see that a fridge appears to be overloaded and running inefficiently. Also in the bottom right photo, you can see a corner of the room has missing insulation. You would need to investigate more to determine the root cause, but you have discovered a problem and now you can move forward to correct it. The AAB Smart HVAC tools are very handy for a walkthrough. These environment data loggers can connect to your smart device through Bluetooth. Through the app's dashboard, you can set up your tools, name the tool, set it to take a reading once an hour or once a day. You can pull current data when you're within active Bluetooth range, and you can also trigger the tool to dump its information into an Excel sheet. And then you can take that data and plot it later to see what is going on. You can see that in the graph on the slide, that data from 5 offices and a community area was collected over a week. These results show us that the offices were able to stay in the temperature bounds while the community area waffled greatly. Now there's evidence to support a closer look at that common area. So, also consider if there's a staff member you know that is always too hot or too cold. Now you have a tool that can properly map it and determine if there is a personal issue or a real ventilation heating issue. Also consider a leaking spot maybe on your ceiling. Is it an old issue that no longer applies? Or use a sensor to find out if the humidity and temperature are prime for an active leak. These tools are no bigger than an egg. They are discreet and simple to use. Take advantage of these smart tools. You will need to download these apps to your smart device. Seek Thermal is the app for the infrared camera, and CPS Link is the app for the HVAC smart tools. Both of these apps are free, and you can download them onto your devices prior to buying the products. For reference, the IR camera is around $250, and the HVAC tools vary between $50 to $200. Once you have your list of BRT opportunities, it is time to consider implementation. Application of your prescriptive measures are what we're going to take advantage next. In the next few slides, we'll see some ideas on how to categorize these problems and the most common problems that are found during BRT. For implementation of your building envelope, you would want to install weather stripping, caulking, insulation around doors, windows, other penetrations. Also, consider implementing a policy for your facility to control your thermostats. A quick behavior control could be to screw windows shut or to lock doors. Also, creating a preventative maintenance program to check on seasonal loads, such as your heat traces, heaters, ACs, and to make sure that you're effectively deactivating them when they're no longer necessary to use. For HVAC, you might have to find a root cause, but other alternatives include ensuring vegetation is not blocking the intakes, whether vegetation be an active bush that's growing or if leaves have fallen from fall and you need to blow away that debris. Implement a preventative maintenance schedule for filters, lubrication, belt controls, and the walkthrough inspection. A policy again on open doors and windows, which could be seasonal in your buildings. Make sure that you consider setbacks on your thermostats, and also adjusting your economizer during different weather conditions. For your air distribution, fix, replace any damaged ductwork, make sure that you clean the grates and the screens, use training and signage to prevent blocking areas such as your intakes and your exhaust areas. Use locks and other controls on interior doors or windows as necessary. Reduce ventilation if it's meeting requirements. Also eliminate and reduce sources of contamination. For lighting, take advantage of the life cycle of the bulb. Also, maintenance costs to justify upgrades. Deactivate old legacy lighting, or if you're overlit. Use signs, train, empower, motivate your district and municipality personnel. Take advantage of daylighting in foyers and stairwells. Install occupancy sensors or photocell dimming controls. Also, it's recommended to not mix lighting types. Each bulb puts out a unique lumen range and color. When you start to mix bulbs, you'll probably overlight your area. Also, visibility could be at odds. Also, staff will probably keep all the lights on, which is an expensive way for a lighting solution. Hot water, check your combustion efficiency, insulation's in place and in good condition if on the hot water lines. Make sure you use your setbacks, use your infrared camera during your inspections, and consider on demand for specific applications, such as your locker rooms or some other heating area that's not used as often. Office equipment, formal policy on ACs, heaters, lighting, coffee makers, etc. Implement a clutter policy and a confiscation protocol. Use kid power or peer power to promote best practices, provide alternatives if necessary, also emphasize safety and indoor air quality. Before we move forward, I want to draw your attention to these other calculators that exist on the DOE's website. The address is in the corner and the website is active. These calculators can help you determine which projects make sense to move forward with and which ones to wait on. Take note of what your baseline is before implementing your building tuning improvements. This will be your E-base, your energy base. Then you can either approach every project individually or from a holistic approach. And you can use the energy benchmarking tools to support what your energy actuals will be, and therefore you can determine your savings. Also keep in mind that this is not always as easy as it sounds due to changes in use, whether that be the room use or scope, whether you started out with one project in lighting but decided to do the HVAC at the same time. This will impact your current implementation costs and will impact your e-savings as well. So keep in mind how you are approaching a project and make sure you update yourself as you go through other projects. Next up is step 4, which is your documentation phase. This is the reporting on retuning findings and your impacts. If you found opportunities throughout your facility, you know what you'll need to do for implementation to fix the identified problems. You now also need to document and calculate the savings so that you can best rank your projects to select which ones you will pursue moving forward with first. When you're choosing the appropriate project, you need to consider the cost, the return on your investment, whether or not the project is simple to approach, will it actually be an improvement to your facility? Also consider the safety portions of all new projects. You need to figure out the energy cost savings for each project. The next few slides offer some examples of walkthroughs within other schools and how to prioritize those projects and document findings and potential savings. So what does a walkthrough look like when you're complete? Break down your list by area and system. Have a place for your observations, and then for the column labeled as effort, this refers to the labor and/or cost required to implement a BRT measure. Low refers to low effort, a few hours to implement and minimum expenditure, while high refers to high effort and more costly expenditures. As a rule of thumb, low is under $1,000, medium is $1,000 to $5,000, and high is over $5,000. In general, the measures that are required for high effort take longer and might be considered as retrofits in certain circumstances. Similarly, as the column labeled potential savings refers to the saving opportunities for that energy use. As in, if the BRT measure is related to lighting, the energy savings percentage is only a percent of the energy used for lighting, not the percent of all energy used in the building. In general, low is the expected savings that are less than 5% of the energy used for that type. Medium means savings within 5 to 10%, and high means energy savings that will range between 10 and 30%. Note that you should have a list of several low and or medium projects. High effort and high saving projects are not necessarily BRT, but if you find a high opportunity, that project should be a one-time project, maintenance notwithstanding. In this slide, I do want to draw your attention to the lighting opportunity found in School 1. This is a behavior change. The lights are not being turned off at the end of the day. And because this is in all of the building, this is considered a potential savings within a medium mindset. In School 2, however, you can see that there is a similar circumstance where current lighting is on after hours in the kitchens. However, this is a low potential savings because this was only found in one of the areas, not the whole building. It is important to consider that every building is unique and should be treated as an individual. You cannot assume behaviors at one location exist at a different location. Also, to draw your attention to the lighting in the auditorium, the current lighting is with metal halides, and it happens that they use this room quite often. Metal halides do not last as long as LED, and metal halides consume a lot more energy than LED. This would be a potential to change out the current bulb with something different that might be able to save the school a lot of time in maintenance, but also a lot of energy and money overall. Also, to address School 3, School 3 had a preventative maintenance schedule plan in mind. However, even though they have this plan, they still had things to tackle in their district, such as exit signs, hallway lights, which were way overlit, and old gym bulbs as well. There's always opportunities, there's always something to find. That's what BRT is about. We also wanted to highlight various energy-saving achievements made by other districts. BRT includes sharing your knowledge with others so that those facilities can also benefit from those energy-saving opportunities. Air pair fans are bladeless fans, so they are discreetly hidden, if you will, in ceilings. Therefore, kids can't take advantage of throwing their milk up into the fan blades. Also, as previously mentioned, hot water in locker rooms might not be a very efficient move. Maybe those locker rooms are not used often enough to justify heating that water continuously. Smart valves in your boilers. Windows, if you have single-paned windows, if your building is older, consider installing windows with e-gas. Lowering your ceilings creates a new square foot area for heating and cooling. Converting to LED is always recommended. Also installing occupancy sensors to light rooms, but also possibly to heat and cool your rooms. Now that you have done the building retuning, you have implemented projects, you want to improve continuously. You do this in many ways. Consider an energy management system, an EnMS, for your facility. Continue to benchmark using Portfolio Manager and/or the Asset Score tool. Continue to move forward with preventative maintenance programs and policies. Upgrade energy-saving projects when you can. Also telling your story about savings from your current BRT projects, like we previously mentioned, sharing and informing others. This encourages behavior changes with the occupants of the building and inspires department heads to fund future projects. Another way to sustain is to commit. An energy policy is a document that is meant to formalize management support for energy efficiency. It also articulates your organization's commitment to save energy for employees and the community and stakeholders. An energy policy speaks to the whole organization. It's recommended to develop an energy team. Champion members from each group that works within the school or municipality are recommended to make up this team. In a school's case, we recommend a school's principal, a financial representative, facilities representative, and an educator to meet and take advantage of this mission. While facilities and finance are chasing down the utility and building operation components, the principal and educator can be informing other educators, assistants, aides, and student body about cultural, behavior, and sustainability community movements. Making sure the lights are off after dismissing a class. If a student club is using a room for an activity, they need to understand that they are impacting the footprint of the school, and they will be the crew at the end of the day, putting back the activity as it were. Awareness, communication, and behavioral changes are all factors in a successful, sustainable movement. Something to consider after the school has representation within the departments would be to create a student team to mimic the actions of the staff energy team, having the students be a part of a club and to work to support the sustainability practices and saving opportunities on behalf of the school. For those interested, this website provides several funding opportunities for municipalities and school districts. When you have a chance, check it out to see how your facility could benefit. Also contact your local utilities to see what incentive programs they have. Programs are constantly being developed and restructured. I recommend you check every other quarter or so to see what's current and what's in the pipeline. If anyone has any questions, PennTAP can be more than happy to connect you with the proper contact for your local utility. And that concludes the BRT portion of today's webinar. I am going to briefly discuss PennTAP's additional services, and then afterward I will review the questions that came through, if any. For services outside of BRT, PennTAP performs free pollution prevention and energy efficiency audits for manufacturers in Pennsylvania. The audit reports provide recommendations with cost savings and estimated project costs and payback periods. For applicable companies, PennTAP also provides assistance in completing grant applications for project implementation. PennTAP's energy, environment, and economy, also called E3 events, combine energy audits, pollution prevention, and lean manufacturing. Each event aims to bring together a lean manufacturer expert with PennTAP's experts to improve the process overall. ISO 50001 is an energy management system standard that establishes a formal framework for industrial and commercial facilities and organizations to manage their energy. 50001 is a volunteer standard that was published in June of 2011. It is based on management system models for continuous improvement and is also used with other well-known standards such as the ISO 9001 for quality or the ISO 14001 for environment management. This makes it easier for organizations to integrate energy management into their overall efforts and to improve their quality and environment management programs. Formal recognition of an energy management system is established by using the ISO 51000 standard or Superior Energy Performance, SEP certification, and the Department of Energy's DOE's new 15001 Ready designation. SEP is a more rigorous energy performance certification developed by the DOE that requires verified energy performance improvements. 50001 Ready is a designation for organizations that have implemented an ISO 50001 based energy management system using the 50001 Ready Navigator online tool. 50001 Ready is great for companies who want the benefits of the energy management system without the ISO 50001 certification costs. For 2017, PennTAP's impacts, we had 147 cases complete, over 5 million economic benefits. We have educated over 800 individuals through our workshops, our on-site, and through these webinars. And we have also engaged over 400 Penn State students. PennTAP is very involved in innovation. PennTAP is in its 2 out of 5 year commitment with the US EDA University Center program to enhance and build economic development in Pennsylvania by leveraging Penn State resources with businesses and community partnerships. We do that by engaging students and faculty in technical design and operational efficiency projects to help entrepreneurs and intrapreneurs overcome hurdles. There are 21 innovation hubs located at Penn State campuses around the Commonwealth to help new businesses and new product creation. Also, the Learning Factory does over 200 student team engineering design projects every year to help sponsors advance technical challenges towards viable solutions. There are mechanics in place to allow sponsors to retain all intellectual property that might be of value to the organization from those sponsored projects. The Learning Factory has been engaging students with company sponsors for over 22 years. The Learning Factory allows students to demonstrate before graduation their abilities to perform in the working environment. It allows them and organizations to build an engaging network with the faculty and staff at Penn State. It allows small companies to benefit from inexpensive but high quality engineering services, and also allows companies to consider a long-term interview and internship with potential students that they might want to hire after graduation. And that concludes my presentation. We'll take a moment and review any questions, and I'll see if I have any answers. I have one. Will the PowerPoint be available to us? Yes. I will have the PowerPoint available to all participants, and also this webinar is recorded and will be available on our website within a few days. Thank you. Does anyone else have any other questions? If not, and you think of something later, my contact information is here, part of the website. You can also contact PennTAP, our website as well, and you'll be committed to somebody who can help you out. So if you think of something later, please just reach out. You can call, you can email. I'll be in my office. All right, so if there are no other questions at this time, I am going to wrap up this webinar. Thank you so much for participating. I will be sending out the presentation within a day or so, so be on lookout for that email. Thank you so much, everyone. Take care.